Hello everyone, my name is Saily, and as promised, I was going to review the practice test 1B. This was a pretty hard test, and it was supposed to imitate Module 2 of the math section on the SAT. Of course, not with all 22 questions, around half, 13 questions in 22 minutes. Each question should have only taken a minute and a half, no more than that. But of course, this is the beginning of the boot camp, and if you took longer than that, then it's alright. This is what practice is for, and this is why I'm making this video, to show you my thought process and analyses through these questions. Of course, I may take a little longer because, you know me, I love to talk, and second of all, I want you guys to understand this to the best of your ability, so therefore, if you were to encounter a similar question again, you will not struggle as much, and you will get the right answer. So, without further ado, let's get into it. So this is the equation sheet that you're given, and this is going to be very important because this is what you're given on the actual SAT, and this is what you were given on the practice test, so it's very important that you utilize it when, you can. Of course, we are going to head to the first question, and let's get to it, okay? Question 1. Bacteria are growing in a liquid growth medium. There were 300,000 cells per milliliter during an initial observation. The number of cells per milliliter doubles every 3 hours. How many cells per milliliter will there be 15 hours after the initial observation? So one thing right now I would take into account is that we are given a lot of values and we're trying to find an end value. So therefore, we're working with a relationship here. The question is, will we be working with a quadratic, a linear, an exponential? How will we know which one is which? Keyword here, hold on, let me turn on my pen, is doubles. That is our keyword, that we are working with an exponential equation. Okay. And because, this will not have a linear rate of change, so we should absolutely avoid using something like y equals mx plus b or something like x squared plus 4. Do not go into there when it says doubles, triples, increases by 200% every year. We are talking about an exponential equation, and that is where we are working with our parent formula. Y equals a times b to the x power over k. The reason why we are working with this and not -1 or something with the x value is because we are given an initial value of 300,000. So this serves as our 0th term, so therefore we don't need to subtract anything from our x. We don't need to do anything special with our x. The exponential equation is good as it is. This is not a geometric sequence. This is just a simple exponential equation. And so we're going to use the values from this problem to plug into this equation to find out how many cells per milliliter will there be 15 hours after the initial observation. All right, so our y value represents what we're trying to get, so we don't know that. Equals a. A is going to be our initial value, and that is going to be our 0th term, which they give during an initial observation. So that would be 300,000. This may be a refresher for your Algebra 1 knowledge. This is something that you guys should have definitely covered by now. All right, so y equals 300,000 times our b value is the rate of which it's increasing by some interval of time. And, well, I've already circled it. It doubles. So our value here would be 2. And x over k. It is an interesting value. It is something that you divide the x by, had it been your situation where you're not increasing or decreasing at every x. You're increasing or decreasing every some x. Like, basically this is saying every 3 x's you're actually going to increase with the whole number, whole value. Right? Because if we had left it at just x, then that means you would double every hour. But the problem says you double every 3 hours, so therefore you have to divide by 3 in order to maintain that relationship that they are giving you. So your equation here would be x over 3, because x is going to be the variable, the amount of hours that we're plugging in, right? So we're given 15, so let's plug in 15. And of course, if you brought your own calculator, you may start plugging in the numbers right now, right? 2 to the 15 over 3. And this simples to y equals 300,000. I'm writing down every single step, and a lot of this is really unnecessary if you know what you're doing, but I want to show you guys every part of the process. Y would have to equal 300,000 times 2 to the 5th power, because 15 divided by 3 is 5. And if you plug that into your calculator, or into Desmos, depending on what you want to use, you should get 9.6 million, which is this one. D is the correct answer. All right. All right. So, moving on to question 2. Which expression is equivalent to 6x to the 8th times y squared plus 12x squared times y squared? That was a mouthful. Okay, so my recommended method is there's actually 2 ways you could go about this. Either you could solve out every single equation here, A, B, C, D, and if you're really good, you can get this done within like 20 seconds. You can eyeball it and be like, oh, I kind of know which ones it could possibly be. Yeah, it's definitely this. And if you're not that kind of person, you can factor out this initial problem given the original factors that they give you. Notice that in every single answer choice, you are given 6x squared y squared. So you can factor out every single part of your equation here and see which one matches up. And I can show you both ways, but for first, I will factor out. And for this, we have to remember our exponential rules. If given the same base of anything, dividing by x to the a over x to the b is simply just x to the a minus b power. This is our exponential rules, and this is from Algebra 1. And same thing with multiplying, actually. It was same concept, actually. I'll take that back. X to the a times x to the b will result in x to the a plus b. So depending on whether you want to divide or multiply each of the answers out, depending on which one you are personally faster with, these are the most important rules that you should know. All right, I'm going to have to erase this because I want some space to work with. Okay, so let's factor this out. Let's divide all of this by 6x squared y squared. Okay, so since this is just an addition, we can an addition of the polynomials, we can just treat them as 2 separate things, right? So it'd be 6x to the 8th y squared over 6x squared y squared plus 12x squared y squared over 6x squared y squared, right? This is pretty simple, and remember, you can only divide the bases, divide the entire term, depending on which part of the term, only by those that have the same base as it, right? So you can't just divide 6 by y squared and call it a day. You can't really do that, okay? So if we were here to factor, we would get, first here, 6's cancel out. That would just be 1, okay? X to the 8th divided by x to the 2nd. And remember our rule, we would just subtract those values, right? If we divide x to the 8th by x to the 2nd, we would just subtract the exponents. So that would just be x to the 6th. And y squared divided by y squared, well, other than the fact that they are the same thing, that would just be 1. 2 minus 2 is also 0, and anything to the 0 power is just 1. So therefore, we just have 1 times x to the 6th times 1. So we have x to the 6th. Now, right here is when you can just stop. You're like, okay, well, I know the answer. The answer must be C. Now, we can go a little further, though. We can go right here. Okay, 12 divided by 6 must be 2. And x squared over x squared is 1, y squared over y squared is 1. So basically 2 times 1, which is just 2. And that leaves us with our other factor, just x to the 6 plus 2. Now this is a way you could factor it out. This might be a quicker way for a lot of you guys. But my personal method is I kind of just like, I expand all of the equations. Now, however, that's not the most time efficient process, and you shouldn't use that all the time. But it is just my personal preference. Sometimes but as I did, like, notice how I didn't even finish factoring out the entire equation, and I knew the answer, because on the SAT you want to be fast. Like, this problem should only take you like 10-15 seconds. Now that might be an exaggeration. Divide it by a common factor that they give you here, 6x squared y squared. All the same thing, so that you know that has to be a factor. And then the moment I got x to the 6th, I know that b couldn't be the answer, I know that d couldn't be the answer, and I certainly knew that a couldn't be the answer, because where did the 2 come from, right? So, okay, on to question number 3. A neighborhood consists of a 2-hectare park. A 2-hectare park and a 35-hectare residential area. The total number of trees in the neighborhood is 3,934. The equation 2x plus 35y equals 3,934 represents the situation. Which of the following is the best interpretation of x in this context? Okay, so immediately right now, x is right next to 2, and we have an idea of where 2 comes from. 2 is the size of that park, right? 2 hectares and 35 hectares. So these numbers are just representing the size of each park. So since we are talking about x, we are obviously going to talk about the park. So anything involving the residential area can immediately be crossed off because we're not talking about y. So B and D are automatically the wrong answer. We are left with A and C. All right? So we are given either A, the average number of trees per hectare in the park, or C, the total number of trees in the park. All right, so a common mistake people would put is, why would it be A? You know, like, it says average number. I don't understand that. Like, that's unfamiliar. And so they would choose A, and that they would not choose A, and they would choose C. And C is incorrect, however, because we're talking about, it says the total number of trees in the park. However, if that was true, why would you multiply the total number of trees in the park by 2? Now you are getting an incorrect value and adding it with another incorrect value because you're probably going to think the same thing for 35. And our answer really wouldn't be 3,934. So C can't be the right answer because the total number of trees can be calculated by the size of that park and the average number of trees per hectare in that park. And therefore, if we multiply that average by 2, we would get the actual value of the entire park altogether. So therefore, our answer would be A. Common misconception on C, just be very careful about that and use my logic. If it was the total number of trees in the park, why are we multiplying by 2? We would have to deal with the average number because when we multiply it by 2, we would get the actual true value of the total park, which is why we're adding it. All right? Okay, on to question number 4. Okay, this one's actually a pretty simple question. You could solve each and every single answer into slope-intercept form and then try to see which one lines up the best, but the easiest and quickest method, and obviously the most efficient one, would just be to plug in a point that matches up with the line, right? So we're given this line and we are basically trying to find which equation could represent this relationship. I don't really need to read this one because the answer, it's a lot of yapping. But the question is at the end, which equation could represent this relationship? Okay, so an obvious point that matches up with this line right here is either 60, 0 or 0, 40. It's up to you which point you want to use. I wouldn't recommend trying to find a point in the middle of this line because graphs are annoying to read and you shouldn't try to read them unless you absolutely have to. So for personal preference, I'm going to use the point 0, 40 following the point format of x, y. So therefore our point will be 0, 40. Okay, we're going to basically plug in the values and just verify, will it create something mathematically correct? Because if it creates something mathematically correct, then that means it is an accurate equation. Since everything is not in slope-intercept form, you shouldn't try to convert to it and then try to see if it don't do that. That is a huge waste of time. Just plug in a value and make sure it makes sense. If the value from this line matches up and makes a mathematically correct statement in one of these equations, then therefore that will be your equation, the correct equation to represent the relationship. Okay, so we have y equals, we are given the point, 0, 40, since I'm zooming in right now, I just want to put that out. We are given y equals 8x plus 12. Okay, so just quickly plugging this in, 40 must equal 8 times 0 plus 12, which is basically 40 equals 12. That is not mathematically correct. We know that A is not the answer. Okay, next. 8 times 0 plus 12 times 40 equals 480. What does that simplify to? That simplifies to, might be running out of room, 480 equals 480. Is that correct? Yes, it is, and therefore that is our answer. Now, if you have a bit of extra time and you worry so much and you just want to check it, you can check it right now. I'll just check it real quick to show you guys my process. Plug in value equals 12 times 0 plus 8. Once again, 40 does not equal 8. So that's not right. Next one, we can just do this one too. 12 times 0 plus 8 times 40 equals 480. It's always a good habit to, if you have extra time, you can check this. But, the answer would be 320 equal to 480. Not mathematically correct. Therefore, that is not the answer. But obviously, B would be our answer. Okay? Because 480 does equal 480. All you have to do, plug in a point on this original line. Next, this one's a tricky one. All right? We're dealing with circles. And if you forgot the formula of a circle or what the area was or circumference, we're dealing with this. We are dealing with this right here. The SAT formula sheet does give us the answers. So how about we utilize that? All right? Circle A has a radius of 3n, and circle B has a radius of 129n, where n is a positive constant. The area of circle B, so we're talking about area, we are given a radius of 3n and 129n, right? And the area of circle B is how many times the area of circle A. So clearly, circle B has a much wider radius. We're talking about like this compared to probably this, all right? So we're asking how many times is B bigger than A, essentially. In order to determine that, we always take the bigger value divided by the smaller value to find out how many times it is. But of course, we don't know the area yet. So how about we solve for that, okay? So referring back to your formula sheet, I know this by heart. The area of a circle is pi r squared, okay? So let's find the area for A. It will equal pi 3n squared. Cool. I'm not gonna completely put it out there. I'm not gonna completely solve for this or expand it yet because I just want to show the other area, which we are talking about area B equals pi times 129, and because that is the radius of circle B squared. All right, so in order to find how many times B is bigger than A, we have to divide both divide B by A. So we're gonna have 129 pi times 129 n squared over pi times 3n squared. There's a common term here, and that's pi, so we don't even have to worry about pi being our answer. And so therefore, we're kind of left with 129n over 3n. And this is a personal note. If you are just dealing with this problem, you don't need to consider n, because in the end, when you end up squaring this entire thing, it will result in n squared. And both B and A will have n squared. So essentially, you can cancel them out right now. You don't really want to worry about. You're trying to worry about that constant in front, 129 over 3, because we are given that stuff. So essentially, we're just trying to see how many times is 129 squared bigger than 3 squared. Okay? So 129 squared, you can use Desmos or your personal calculator. 129 squared would be 16,641 divided by, and then next we have 3 squared, which from heart is just 9. And it's kind of clear what the answer is now, because it obviously can't be the first three. They seem pretty small, but to verify on your calculator, divide by 9, you're going to get the answer 1,849. Right? Common mistake students will make, they'll just put 129 because that's the last number they saw. This will probably be like their last question. They'll be like, I don't really understand it. Good luck. YOLO. Don't do that. Try to have enough time for this question. Another common mistake is that they will try to divide 129 by 3 because they just didn't want to use the formula, or they forgot what could possibly be the area of a circle. I don't know why. They give you a formula sheet. Please use it, okay? 129 over 3 would give you 43. That is a common distractor answer. I don't really know how they got B, but they suspected 43 couldn't be a right answer, so they just doubled it. Who knows what their thought process was. Yeah, but the answer is D. All right, 6 is it's a pretty easy question, but the frequency table summarizes the 57 data values in a data set. What is the maximum data value in the data set? Okay, so this is just a elementary stat question. We're asked for the did my pen just turn off? Okay, maximum data value. Maximum data value. So we are going to worry about this and this only. Do not worry about the frequency. We are asked for the maximum, therefore the biggest value that we are given. Largest value, okay? I know I'm this old. I'm in AP Calculus BC. I'm still using biggest, okay? Don't judge me on that. Okay, so this is pretty easy. What is your biggest value for the data? 14. Our answer is 14. A common distractor right here I could easily spot is students would be confused. They would look at the thing and be like overwhelmed. There's so many numbers. Which one do I choose? Oh no. Is it really 14? I feel like it can't be 14 because it looks like it's going in order. What if it's 11? No, that would be 11 would be the largest value in the frequency, and the value it correlates to would be 11, so students might be like, that's the maximum data value. That may be the most prevalent data value, but they did not ask you for the mode, they just asked you for the maximum. The mode is the value where it has the largest frequency in a data table, like right here, like this would be like your mode. Some people would be like, oh yeah, 11 has to be our maximum because it has the most, it appears the most amount of times. That's not what the question is asking. It's asking pretty relatively easy question. Just 14. 14's your answer. Just box that. Okay. Okay, on to question 7. A circle in the xy plane has a diameter with endpoints 2, 4, and 2, 14. An equation of this circle is x minus 2 squared plus y minus 9 squared equals r squared, where r is a positive constant. What is the value of r? So this kind of just goes back to a bit of geometry. We are given a circle, right? We're dealing with circles here. It has a diameter with the endpoints 2, 4, and 2, 14. An equation of this circle is that, okay? We're trying to find what r is, and r would be our radius. Right back to circles. Don't we love circles? I know I do. So let's start off with the vocabulary that they give us. Diameter is twice the radius. So that might be helpful, okay? And we're given with the endpoints. Oh, and by the way, the diameter is just a line passing through the center. That is the entire width of the circle. Meanwhile, while the radius is from the center to the, oh, that was weird, the center to any point of the circle, right? So diameter is just twice of that, so that's why it's 2r. And of course, the diameter with the endpoints 2, 4, 2, 14. In order, we're trying to find like what's that length, so then we can find the radius, if you guys know what I mean, right? The length of 2 to 4 to 2 to 14. Quick shortcut. Right now, that might be a signal for you guys. Oh, let's use the distance formula. You don't have to. If one of the values are the same, you just have to subtract the other value. Like if x is the same right here, 2 and 2, you do not need to use a distance formula for something this simple. Just subtract the values. The y values right here. 14 minus 4 equals 10. Had it been the other way around, like 4, 2, and 14, 2, since the y values would be the 2's and the 2's are the same, you don't even need to consider them, just subtract the x values. Same thing applies in cases like these. Now, of course, if you were given points like 3, 2, and 5, 6, that's your diameter, then yes, you would need to use the distance equation to find out the entire length of that diameter. But of course, this is a relatively simpler question and that you can easily use a shortcut on. So therefore, you can just subtract the values to find the difference, the length, that diameter, right? So the diameter, remember, which is twice the radius, equals 10. That is what it is. If we solve for r, divide both sides by 2, r equals 5. So our value would just be 5. Remember, we don't need to include units in our answers, and I think it's physically impossible to try to type in any words or units into the free response question, so College Board won't even let you. So it's just simply 5, right? Okay, so question 8 is a somewhat trickier question. I wouldn't really say so, but you do need to know how to convert from radians to degrees, because the measure of angle r is in 2 pi over 3 radians, and the measure of angle t is 5 pi over 12 radians, and that is greater than the measure of angle r. What is the measure of angle t in degrees? If we know that angle r is 2 pi over 3 radians, and t is essentially just r plus 5 pi over 12 radians, we just have to add these values together. Now, it didn't say 5 pi over 12 radians, 12 pi over 12, 5 pi over 12 times greater. We would just add, because it didn't say times, it just says greater. So we're just adding here. So we're given 2 pi over 3 plus 5 pi over 12. Okay, short and simple. Very, very, very sweet. All right. Of course, we can't peacefully add this together unless we're gonna have the same denominator, and in order to do that, we just find a common factor. And since 12 is actually divisible by 3, we can actually just multiply only one of them by the factor that gets to 12, right? We would multiply 3 by some sort of value that would get it to 12, so we can add these together. And that common factor would be 4, so we are going to be left with, nope, my bad, not 2, meant to say 4, right? We multiply the top and the bottom, numerator and denominator, by 4, get 8 pi over 12 plus 5 pi over 12 equals 13 pi over 12. Now that would be the measure of angle t, however that is in radians, and we would need to convert to degrees. Usually between degrees and radians, to convert you would use either pi over 180 or 180 over pi. And I have already done geometry like years ago, and sometimes I just don't really remember, wait, which way is which way? But the easy way I know is that angle t, like degrees are just in numbers only. They don't include pi, they don't include that. Angle t, any kind of angle in degrees would just be a flat out number, which is what they're asking for, A, B, C, or D. And radians would have to be in terms of pi. So whichever, if I want to go to degrees, I have to get to just a normal number with no pi. And if I want to go to radians, I would have to multiply in a way that I would have to have pi in my answer. So we want to kind of get rid of pi. So 13 pi over 12, we're going to just multiply by either pi over 180 or 180 over pi. And I believe we should use 180 over pi, because that is there's only 180 degrees in 1 pi radian. All right, so we're gonna cross that out because this would cancel out. We're gonna have 13 over 12 times 180, and this is where we can get just a flat out number, which is how we know that we are going to get an angle in degrees. And you can do this on your calculator, do it in Desmos. 13 over 12 times 180. Your answer would be 195 degrees. C would be the correct answer. Okay. Other answers might have resulted from trying to just convert the regular angles that they give you without any adding just into degrees. That's not the right answer. You're going to need to add them, and then for t, of course, we're trying to find angle t. Okay. All right, next question. A certain town has an area of 4.36 square miles. What is the area in square yards of this town? And for reference, they actually already gave you the conversion. 1 mile equals 1,760 yards. So we're starting with 4.36 square miles, and we are trying to find the area in square yards, right, of this town. So they didn't give us the square of anything. They just gave us the regular miles equals 1,760 yards. So to multiply 4.36 by 1,760 would be an incorrect assumption, and that is how you would actually get the answer of B. That is a very common mistake. You don't want to make that mistake. They said square miles. It is square miles only. We are not talking about regular miles, and they're trying to find the area in square yards. They're not talking about regular yards. You're like, okay, so Saley, how are we going to solve this? They didn't give us the conversion. What do I do now? Make the conversion work for you. We are talking about square, right? So if we have 1 mile equals 1,760 yards, we can just square both sides. Therefore, a square mile would equal 1,760 squared would be 3097600, 3 million square yards, right? That was magical. And now, since we are in terms of square miles, we can finally convert to our square yards, because we're talking about square yards. We're talking about square miles and square yards now. Great. This is awesome. And for every one, we can just set up an equation for this. We are given 4.36 square miles. We can multiply this by given the proportion that we're in this equation right here that we just came up with. There would be 3,997,600 yards squared over 1 mile squared. 1 square mile. Mile squares cancel out. We would end up getting 4.36 times 3 million. You get the point. And you don't even need to put this in your calculator. The answer is kind of obvious, but you can verify this if you want. The answer is D. This was just a complicated way of explaining it. If you understand proportions, you understand how to convert, you would have just multiplied 4.36 times 3 million something. You would have called it a day. The answer would have been D. So that is your answer. Okay, so question 10 is a pretty decent question. I would say it's a moderate question. However, I think the SAT has this one marked as the harder question. So for question 10, for line H, the table shows 3 values of x and their corresponding values of y. Line K is the result of translating line H down 5 units in the xy plane. What is the x-intercept of line K? So we're given lines, so that should tell you immediately we are going to work with a linear relationship, perhaps. I don't know. Pre-algebra is coming in clutch. Y equals mx plus b. Sound familiar? And we're knowing that line K is essentially line H, but translated down 5 units in the xy plane. And right now this doesn't make sense because you're like, oh crap, I have some lines and I don't really know how I'm supposed to relate them to each other. And what is this whole table for? This table is for line H, remember? So we are not talking about line K yet. We have to solve for line H before we start talking about K. An easy way to do this, either you can use the linear regression function in the TI-84 to just get the equation out for you. However, that's not a very common skill among anyone. So we're going to solve this the simple way. Y minus y1 equals m times x minus x1. This is how we're going to find our equation. All right. We don't know m, our slope, and remember this is our point slope formula. This is how we can find the linear equation of any two that passes through any 2 points. And so this has 3 values of x and their corresponding values of y. So line H will pass through each one of these points, so we can pick any points that we want to. So in order to find the slope, which is m, we would just do y2 minus y1 over x2 minus x1. That would be, sorry, I'm gonna have to write down here, be 130. Okay, maybe I don't want a negative number, so I take that back. I'm going to use 160 minus 130 over 23 minus 18. Now, of course, you can use any other values. These are just the closer ones and easier ones to subtract because they're smaller. Be 30 over 5. Therefore, our slope would just equal 6. So now we know our m, okay? And then we can choose either 18 130 or 23 160 to plug in, or even 26 178. But for convenience purposes, I'm going to choose the smallest values. And of course, that would be 18 130. So this would be, we just plug into our y1 and x1 parts, respectively. So y minus 130 equals 6 times, since 6 is our slope, x minus 18, right? So we're going to solve for this. Y minus 130 equals 6x, and then 6 times negative 18, it's just 108, negative 108, add 130 to both sides, 130 to both sides. Your equation of line H, remember, this is line H only. Add 130 to both sides, 6x plus 22. Okay, but however, this is just line H, so we can't really work with this yet. We can't find the x-intercept yet because we would have to talk about line K. And in order to get line K, we just have to translate line H down 5 units. And by down 5 units, that means our y value, all of our y values would just go down by 5. And in order to impact the y values just down by 5 units, we're not shifting left, right, or anything. We're shifting up and down. We would have to deal with our b value here, our y-intercept. We are going to have to subtract 5 from that. So therefore, k would be y equals 6x minus 17. All right? So in order to find the x-intercept, remember, we always set our y value to 0 in order to find that x value that, makes y 0, because that's the whole point of an x-intercept, where we have some sort of value for x, but the y is always 0. So 0 equals 6x minus 17. Add 17 to both sides. We have 17 equals 6x. Oh, my bad. Okay, so this is a arithmetic error right here. I meant to add 17. So therefore, this would be subtract 17 because I just traced back into my old equation, 6x plus 22. It should be plus 17, not minus 17. Okay, my bad. Divide both sides by 6. And our x value should be negative 17 over 6. So therefore, our answer would be D. Luckily, my arithmetic error was very small, but if you're starting to see that your answer isn't lining up with any of the possible answers, and you know that you did most of everything right, it is most likely just a simple error like that, just forgetting the sign. Luckily, it wasn't a major mistake, and I was able to solve through it peacefully. Okay, so we are in question 11 now. In the xy plane, the graph of the equation y equals negative x squared plus 9x minus 100 intersects the line y equals c at exactly 1 point. What is the value of c? Okay, so we are given a negative parabola, and we're trying to find out when it intersects a straight line because there's no variable. It's just y equals something at exactly 1 point, which would be the vertex. And remember, the vertex is either the maximum or minimum of a parabola. So essentially, we're just trying to find out the vertex and what's the y value of that vertex that we are given. Now, an easy way out of this I would preferably use is either your graphing calculator or Desmos, which is the better option. I would plug in y equals negative x squared plus 9x minus 100. And then in a separate equation, I would just y equals, and then plug in a, b, c, and d, because that is your only way of, like, let's say you're running short on time, or this might even take quicker. If you know you're not too strong with your algebra skills and you don't want to really test it and get the wrong answer, this is the easiest way to do it. When will your graph look like this is basically what you're trying to find. When will it have a straight line just crossing through that vertex right there? Of course, there's a way of solving this algebraically, and that is with the formula x equals negative b over 2a. That is how you find the x value of your vertex, given that your standard form is ax squared plus bx plus c. Now, back in my naive days when I first took the SAT, I solved everything by hand, so guess which method I used? I used the algebraic method, and I did get the right answer. However, it wasted so much time. But I'm going to show you anyway, because, you know, if you have a bit of time left and you just want to check, even though for some reason you don't believe your calculator, this is exactly how I would do it. 9 over 2 times negative 1 equals negative, nope, it's not negative. I take that back. It's 9 over 2, which is just 4.5. And then in order to find that value of y, I would just plug it back in. Y equals negative of 4.5 squared plus 9 times 4.5 minus 100. And if I were to do that, I would get some value, but it wouldn't be in fraction form anyway. So I would just plug it in and verify that the decimal equals one of the fractions, which you could just put out into your calculator. 9 times 4.5. And I'm just algebraically solving it right now, showing that there is a way to mathematically solve it if you're like kind of like freaking out. So this minus that minus 100, get a negative value. Y equals negative 79 point, oh, negative 79.75. You could use your calculator to convert this into the fraction, but you can just verify right here that your answer would be C, negative 319 over 4, and just plug it in your calculator. You should get the same value. This is just a longer way of doing it. Of course, it took a little more thought. And of course, you can still mess up, which is a little scary. You don't want to. But some common misconceptions is that students won't really know what to do. They'll just think C is like the y-intercept. So they'll just put B, negative 100, not the right answer. That's a distractor. And D, this is for students who do know the formula, negative B over 2A to find the x value of the vertex. However, they only found the x value. 9 over 2 is only the x value. And it's actually incorrect too, because negative 9 over negative 2 is not negative 9 over 2. It's actually 9 over 2, which is positive. So those are just some easy distractor answers. In the SAT, there will be some easier questions and some harder questions, and this for sure is definitely one of the harder questions. My first time taking the SAT, I didn't study, and this was one of the questions where I kind of just guessed or like skipped. I don't want you guys to be put in that same position, so I'm going to go over the solution on how you would actually solve this. Now, there's no exact or kind of like mentally easy way to digest this, other than the fact that we would just have to plug in these values. For each real number r, which of the following points lies on the graph of each equation in the xy plane for the given system? Now, in order for a point to lie in the graph of each equation in the xy plane, the values of x and y have to satisfy the equation in which it is mathematically correct, reminding us of a question that we actually solved earlier.
From pressbooks.pub. To satisfy or make an equation true means the left side and the right side of the equation will be equal once we substitute the variable with the correct value, i.e., the solution.
Okay, thanks. So she basically just explained what to do. So there's no really easy way out of this question. For easier questions, it might take you only 20 seconds or 30 seconds to get through. This is definitely a question that might take you up to 2 minutes if you're pretty quick about it. 2 or even 3 minutes. That is a stretch, but this is one of those questions where you can spend a little more time as long as you know what you're doing on the earlier questions. So remember, all this is just a way of saying x and y. We are talking about our points x, y, and r is just a representation of something, right? So in order for this to be true, when we plug in x and y, it has to be mathematically correct. Okay, so starting off with our first one, we're going to treat, we're just going to plug it into our first equation because it looks easier to work with. R over 5 plus 7, and then plus 3 times negative r over 5 plus 35 equals 7, because honestly there is a mental shortcut. However, it's very easy to mess up on that, and that is how you can get all these wrong answers right here. So 2r over 5 plus 7 plus, oh, I would not add actually, I would just subtract minus 3r 5 plus 35, and this must equal 7. Oh, yeah. Okay. So this already looks pretty complicated, and I'm not feeling very hopeful about the right answer here. Negative r5, 7 plus, I have a calculator. I don't know. I'm doing this mentally, but I'm just 42 has to equal 7 minus 42 minus 42. Negative r over 5 equals 7 minus 42. Negative 35. This is just interesting. We're not getting anything that works. This is just... Are we saying that r just equals anything? Because we can multiply that by negative 5, and we would end up getting 175. R is 175, but we're not trying to find what R is. R is just a placeholder for something. So this would not be the correct answer, because where are we going with this? Even I don't know. Right? we're trying to get one side equal to the other in terms of just mathematical numbers, not variables. So let's plug in the next one. 2, negative 3r over 2 plus 7 over 2, and then plus 3r, because r is going to be treated as our y value, equals 7. Feeling kind of hopeful about this one. So this would, 2's would cancel out. We just have negative 3r plus 7 plus 3r equals 7. Ooh, I like this one. So then negative 3r would cancel out with the other 3r. So then we are left with 7 equals 7. Mathematically correct. Now, I wrote out a lot of steps, and I took quite a bit longer because, you know, it's 9 p.m. and I'm a little bit tired. But had it been the morning of the SAT, I would have been feeling pretty good about this one because all it is just substituting and finding when it is mathematically correct. Now, you can verify this with C, where x is actually r and y equals 2r over 3 plus 7 over 3. You get the point. You will not get a mathematically correct answer. So therefore, that wouldn't be correct. Now, if you have extra time, you can verify C and D. However, I'm not going to spend any more time with that. But remember my point with A. If your answer is not getting anywhere and you're really getting R equals, like, that doesn't tell you anything. So it is just a distractor answer. And C and D they come out of mathematical errors. So just be aware. Just be aware of what is right. Yeah. Okay, final question. Question 3. This took a while, but I'm reviewing each question very thoroughly so you guys can understand this. But I just want to make a note on question 12. I did solve out the other equations. And actually, you wouldn't even get something mathematically correct. You would just get r equals something. If you're getting r equals something, this isn't helping. You have to get the key to this one. Find a mathematically correct solution. Anything that ends up resulting in r equals something, that is not going to be your desired answer. So 13 is a free response question, so we're going to have to do a bit of work here. We can't just plug and chug. We are given that the perimeter of an equilateral triangle, so it's an equilateral triangle, has all 3 equal sides, and the perimeter is 624, and the perimeter is just like the length of each side combined. So if each side is equal, divided by 3, each side would have to be 208, all right? Now that's a common misconception. Some people would just read this, be like, oh, yeah, the answer is 208. No, it's not, okay? They say that the height of the triangle is k to the radical 3 centimeters, where k is a constant. What is the value of k? Now you might be like, oh no, oh my gosh, what am I supposed to do? I don't know this. Right. However, k to the square root of 3 reminds me of something that the formula sheet actually gave us. It gives us something about special right triangles. And where do I see something about something multiplied to the square root of 3 being potentially the height? That'll be right here, our 30, 60, 90 triangle, throwing back to geometry. Oh, the good old days before calculus. All right, so we are going to be given that. And you're like, wait, but isn't that like the base of that triangle? Like, how does that have anything to do? That triangle doesn't even look like it's equilateral. That's right, because in fact, fun fact right now, so a bit of a math lesson, all a 360, 90 triangle is just half of an equilateral. Ignore how that really kind of doesn't look like an equilateral. Sorry. We can use the formula sheet to plug in these values right here. 2x and x, right? Okay, so we're going to have 2x. This must be x, and this must be x. This must be x. How they derive the 30, 60, 90 triangle, they cut an equilateral triangle in half, and that's essentially how they got this. And if you reflect it on the other side, this should match up, right? If if both top angles are 30 degrees, we add them together, the equilateral angle here would just be 60 degrees, which is equal to all the other 60 degrees. So just a bit of geometry knowledge. This is an equilateral triangle, and also the 2x is right here, just 2x. So therefore, now you've learned it. If you haven't already, a 30, 60, 90 triangle is just half of an equilateral. So when we put them next to each other, this is where we can start to figure out things. All right, angle degrees, I don't know if that's necessarily helpful. Since we already figured out that one side, and actually every side, must be 208. Sorry, this actually should be treated as an x as well, because x times the square root of 3, all right? That is your height of the 30, 60, 90 triangle, and the longer diagonal side right here is 2x, and the shorter relatively horizontal side would just be x. But yeah, as I digress, that's basically what k is. We're just treating k as x in the 30, 60, 90 triangle. And if we know that 208 is one of the sides, that diagonal side right there, 208 by 2 divided by 2, our x must be 104. Now, I took a considerably long time doing this, and this is because I have not reviewed or studied for the math section SAT at all, but since you guys are, and you guys are watching me solve this problem, definitely touch up on the relationship of the 30, 60, 90 triangle, and then the relationships of 45, 45, 90, okay? That is how we got our answer. X, or technically K, should be 104. That is that constant multiplied to the square root of 3, which is the height of that triangle, of the equilateral triangle. All right, so that concludes our huge and long review video. If you are still listening at this point and haven't fallen asleep to my long lecturing, congratulations, you made it to the end. This is exactly how to score a perfect score on your module 2 of the math section, or at least in this practice test. But if you can apply these concepts, remember my thought process and rationale behind everything, you should be able to get a few more questions right when you return and take another module 2, section 2 of the math SAT. Now, of course, if you have any questions, please message me in the group chat or privately on Schoolhouse. I will be happy to answer any questions. Now, if I'm recycling this video and using it for a later time, you may just ask the question in the YouTube comment section. I will happily answer them. Thank you for watching, and thank you for sticking around. This took me quite a bit of work, so thanks for checking this video out. All right, see you later.